Hello, I'm back, and now we want to continue talking about what atoms are. So, this is not a geology class, although in the next unit we're going to be talking about the solar system, and you will need to be knowing a little bit about geology. But for right now, I don't think that you should recognize the rock granite. But when you get finished with the next unit, you will understand what granite is. So granite is this kind of a speckly igneous rock, and it's very pretty looking, and they sometimes use it to build government buildings with it. So if you look at the granite rock, you'll see it's speckly, and each one of those speckles in it is a different kind of mineral. And so if you look at granite under a hand lens, you'll notice it has these clear crystals, and those clear crystals are the mineral quartz. So rocks are made of minerals. Now, if you were to take that mineral quartz and hit it with a hammer, well, you'll end up with more pieces of quartz. But let's go ahead and keep hitting the quartz fragments with our hammer until we can start to see the atoms. And then you would notice that the atoms are hooked together in a particular kind of order. So that makes up the crystal structure of that mineral. And you'll notice that quartz is only made of two different kinds of elements. So it's made of the element oxygen, and then it's made of the element silicon. And the chemical compound is SiO2. So that's what quartz is composed of. And if you were to take the quartz molecule and then hit it with a hammer, you could break it apart into the two atoms of oxygen and silicon. So what an atom is it's the smallest unit of matter that has the chemical properties of that matter. So like, for example, you could have a block of silicon, and it's going to be a silverish metal, and it also has a certain hardness. And when you keep hitting that thing with the hammer, you always end up with something that's silver and is easy to cut, for example. But by the time that you get down to an atom, it's going to be the last piece of that silicon that still has all the chemical properties of silicon. So what are some properties of atoms? Well, the first one I wanted you to know about is the size of the atom. And so we said, or you should know, that a meter stick is, I can't fit it on there, but it's about, well, about that big. All right, so this is about the size of a meter. Okay, now imagine that you could take that meter stick and chop it up into 1,000 pieces. And then take one of those things and chop it up into 1,000 pieces. And then take one of those things and chop it up into 1,000 pieces. And then take one of those things and chop it up into 10 pieces. Each of those little pieces would be approximately the diameter of the atom. So it's going to be 1 times 10 to the negative 10th meters across. And we have a special word for that. We call it the angstrom. Now, you don't need to know the 10 to the negative 10th. For that matter, you don't even need to know the angstrom. You do need to know it's small. It's so small that you can't see it with the naked eye. It's so small that you wouldn't even be able to see it with the kind of microscope that they would have in biology. However, there are these things that are called electron microscopes that we can use to see individual atoms. And so if you look at that picture there, the one that looks like it kind of has fuzzy balls that have been put together, those are actual atoms. And do you notice that the atoms, when they hook together, make a particular pattern? And that's true for atoms. When they hook together, they make a particular crystal structure that goes with it. So in the picture that's underneath there, that just gives you a rough estimate for how large objects are or how small objects are. And then the very last picture there is the picture, or the one that is off to the left. That finally is the size of the atom. Now there's a very good video that I want you to watch, and it's called Powers of 10, and it's on YouTube. So go to the internet, just type in Powers of 10, go to the videos, and it'll pop up, and then go ahead and watch that. Okay, did you watch it? Okay, did you like that music? Okay, that's 1970s music. So that particular video came out in the 1970s. I especially like that organ music there at the very beginning of it. But what you should have saw was a guy laying on a blanket there in Chicago, and then the camera takes a picture of him and starts to back off, and then first the camera is 1 meter away from him, then 10 meters away, then 100 meters, and it just keeps on going until finally you're in outer space and you're looking at groups of galaxies. And then it zooms back in, zooms in on his hand, and eventually it ends up in looking at the nucleus of a carbon atom, which is making up the DNA of a cell that's in his hand. So pretty impressive. But again, that just gives you an idea for how small objects can be, and also how big objects can be. Okay, let's also do this one. So another property of atoms is going to be their mass. So the mass of a carbon atom is 2 times 10 to the negative 23 grams, and 1 gram is the mass of a paperclip, just to give you an idea for what 1 gram feels like. So atoms are incredibly small. You don't need to know the number, but you should know that if you went to the best chemistry department and you took a single atom and you put it on the scale, what's going to happen? Nothing. Okay, so you're not going to be able to read the mass of a single atom. So that's the reason why in chemistry they don't measure 1 atom, they don't measure 10 atoms, they don't measure 100 atoms at a time, they measure a mole at a time, and it turns out that a mole is about 6 times 10 to the positive 23 atoms. So when you're measuring that many atoms, now you actually get a readout on the scale. The constituents. So everybody ought to know this, that the atom is composed of a nucleus, which contains protons and neutrons, and then in orbit around it are going to be the electrons, and you should know the charge. So electrons have a negative charge, protons have a positive charge, and then neutrons are electrically neutral. And then you should also have a rough estimation for the masses, so that imagine that you've got 2 bowling balls next to each other and then a ping pong ball. So the 2 bowling balls represent the proton and the neutron. They're roughly the same. The neutron is just a little bit heavier than what a proton is. And then the electron would be that ping pong ball. So that both protons and neutrons are about 2,000 times more massive than what the electron is. Okay, in our next segment, we're going to talk about what is the force that holds the atom together. So I'll see you in just a few moments.